Hi, we are the McGuffins team, and we are going to demo the first phase of our project. So, in our case, we have decided to go with AWS for setting up our infrastructure. We have three instances with this particular one acting as the master, and these two are the slaves. And once we have brought up these instances, the first thing that we have done is set up the passwordless login. So now we have just logged into the master node, and as you can see, these are the IP addresses of the master as well as the worker, and passwordless login has been set up. So let us just try to log in into worker 2. So here we are, this is the IP address of worker 2, whereas let me just exit. This is the IP address of the master. So one way we are able to log into one of the workers, and this is the other worker. So the same thing has been done even for localhost. So passwordless login has been set up from the master. Now I'll just show you what happens on the other two workers, as we are just trying to there you go, the other workers are able to log in without passwords. The last worker also is able to do that. And let me just show you the etc host file, which this is the master node which we just tried doing a passwordless login into. So now that passwordless login has been set up, we'll just go ahead and format the main node as indicated. So the formatting is done for the master node, and let us go ahead and start off all the Hadoop instances. But this is going to take some time. So now that Hadoop has started, I'm just going to show you the UI. This is on the master, and we have 3 live nodes, which are the other two worker nodes that we have internally registered for Hadoop. So now that Hadoop is set up, we'll go ahead and add the create the Hadoop distributed file directories and add our CSV files there. So to do that, so the directory has been created. I'll just go ahead and add the files. So our CSV files have been copied locally using the SCP command. So we have all the files available here. I'm just moving it to the DFS system. So there we go, it's been added, and just for confirmation, let us just look at the contents of the file system folders. Yeah, as you can see, we have moved the AREL as well as the other dataset file here. Now that this is set up, we'll go ahead and start Spark on both master as well as slaves. So we have followed the Spark SPIN configuration and set up the master configuration. Now we are just going to start it. So the master has started up now, and so in the worker 2 we are setting up Spark. We have just given the URL and starting up the Spark worker node right now. Oops. So there you go, it's one of the worker Spark nodes have started. We'll go ahead and add the same worker in the other worker node. So both of this has been set up. Let me just show it on the client. Yeah, as you can see, this is the UI for Spark, and both the workers have registered themselves here. So now that all of this is set up, we'll just invoke the Spark shell and start executing our queries on it through the file loaded in HDFS. So we are loading the latest version of the GeoSpark jar into the Spark shell. So it has picked up the Spark context with the local setting, and we are running this particular instance on the master itself. So let me just show you the code that we have written. So these are the import statements for performing the spatial range query. We are picking up the file from HDFS. These are the files that we have previously shown, and loading it into Spark context and performing the spatial query. Let me just execute this. So point object has been loaded, and now we'll perform the query and print the results. So as you can see, the result is 445, and let's go ahead and execute the spatial range query with indexing right now. So we are building an R3 index over here on that particular data. So the index has been built, and now we'll execute the same query and look at the result size. So as expected, the size remains the same, but the query returned quickly. So now we'll go ahead and execute the KNN query. On the point data. So we have loaded the data now, and let us see what are the k nearest objects to this particular point. So there are 5 points which are closest to that particular coordinate that we wanted to query. So now we'll go ahead and execute the same query using an index. So the index we are using here is R3, and the index has been loaded, and now we'll execute our query and see how quickly it returns. That was fairly fast. And now we move on to the spatial join queries, and as part of this we are going to use a equal grid for the spatial join, and Let me just load the data first. The data has been loaded now, and we are going to do spatial partitioning using equal grid, and that is done. Now we'll look at the join result. So the result is 25,743, the size of the spatial join query. And after the spatial join has been performed, now we'll do the same operation for the data using an index. So we are still using the equal grid here, but along with that we are going to pass an index, an R3 index. So the partitioning is done. Now let's see what the join query results, how fast it's happening with the indexing in place. So this was fairly faster. It was visibly faster than the rest of the results that we have seen with indexing. So we get the same result but fairly faster. Now we'll do the last spatial join query where we use an R3 grid instead of a equi-grid. We have loaded the data now, and now we are doing spatial partitioning using R3 grid. Partition the data, and now let's perform the query. Yes, there we go. The result set is as usual the same, and we are ending our demo. Our team is Akhil Ravichandran, Sahil Dayarkar, Darshan and Prashant. Let us know if you need anything else. Thank you.